Okay, we're going to get right to it. Our first speaker is Kate Wilcox, who is an ORISE Research Fellow with the U.S. Forest Service Pacific Southwest Research Station, which is a mouthful, studying post-fire meadow restoration in the Sierra Nevada. She received an undergraduate degree in fishery resources from the University of Idaho and a master's in geology from Fresno State University. She is currently based out of Reno, Nevada, but is originally from Humboldt County.
Thank you so much for the intro. Thank you for coming. We had some really inspiring talks before this, and now okay. Today's talk is about leveraging post-fire sediment in order to restore incised meadow channels in the Sierra Nevada. So the general narrative is that post-fire sediment is transported downstream and negatively affects ecosystems and infrastructure. However, we are exploring using low-tech process-based restoration structures such as Beaver Dam analogs in order to keep that post-fire sediment in headwater meadows while simultaneously restoring these incised ecosystems. So meadows are natural depositional landscapes. They store sediment in their channels and across their floodplains. And in turn, the meadow vegetation locks that sediment in place, protecting the surface from erosion. However, land use practices such as overgrazing or road building cause that meadow saw to break apart and can lead to severe channel incision. This can lead to decrease in water table, release of stored carbon, and also the encroachment of upland species such as conifers. A similar scenario takes place when high severity fire removes the majority of vegetation across a landscape, and this can lead to increased runoff and erosion, and post-fire sediment loads can increase up to multiple orders of magnitude. However, these two scenarios overlap when you have incised meadows that have been severely burned by wildfire. So we expect these high post-fire sediment loads to be coming downstream, and we want to keep it in these headwater meadows, but in their current condition, these incised channels can't retain a significant amount of sediment. Low-tech process-based restoration, such as Beaver Dam analogs, are an increasingly common method for treating incised stream channels. They're an increasingly common alternative to using heavy machinery as well. So you can do this type of restoration in more remote settings, and is also can be cheaper. So to study the effects of fire and restoration in incised channels and incised meadows, we selected 6 study meadows across the Sierra Nevada. So we have 3 study meadows in the northern Sierra and 3 in the central southern Sierra, which we'll refer to as the northern and southern sites from here on out. So within those 2 different clusters, we have 3 different treatments. Our first treatment are burned, unrestored meadows. So meadows that are incised, have been recently burned by wildfire, and have not had tech process-based restoration structures installed in them. Our second treatment are burned, restored meadows. They're meadows that have been burned by wildfire recently and have had process-based restoration structures installed in the channels. Our third treatment are unburned, restored meadows. So these are meadows that have not experienced recent wildfire, but have had restoration structures installed in the channels. Okay, so this is annual precipitation at the 2 different sites, but basically it's just a timeline of our project. Fire took place 1 to 3 years before restoration during times of drought, especially in the southern Sierra, and then restoration took place during much wetter years. So we measured the geomorphic effect of fire and restoration in 2 different ways. We measured the amount of sediment captured in the incised channels, as well as the grain size of that sediment. So in unrestored channels, because they're incised, we expect the fine sediment to continue to be moved out of the system and for the sediment to the remains to be coarser. In the restored channel, we expect the restoration for sediment to settle out and for sediment to grade behind these structures. Looking at unburned versus burned restored meadows, we expect that the amount of sediment available for capture behind these structures to be greater and that sediment to be finer. So based on those different concepts, we developed the following hypothesis. Other two trees. For the size, we expect grain size unrestored, and then at the unrestored meadows, we expect grain size to fall in between the other two treatments again. So to measure sediment capture, we used a method called V-star, which is the volume of sediment deposited in a pool by the pool volume at base flow. This is just a relative volume that allows us to make comparisons across different sites with different geomorphologies. But basically, the higher the V-star, the higher the percent of the pool is filled with sediment. Okay, so this shows V-star across all of our three treatments. So looking at the median V-star, which is the bar in the middle of the box plot, at the burned unrestored meadows, median V-star was lowest and median V-star highest at the burned restored meadows. So basically at the burned restored meadows, the percent of the pools were the highest percentage of pools filled with fine sediment at the burned restored meadows. And then at the burned restored meadows, the median V-star fell in between the other two treatments. So these data do support our hypotheses, but I do want to turn your attention toward the burned unrestored plot because behind this data is an interesting story around large wood and meadow self-restoration. So if you break apart this plot by meadow and by year, you can see that at Fall River Meadow, the median V-star basically doesn't change from 2023 to 2024. But at McCreary Meadow from 2023 to 2024, we see a significant increase in the amount of sediment captured in this meadow. We attribute this meadow having a much higher density of naturally recruited large wood than Fall River Meadow. So the trees, the conifer has encroached directly up to the meadow channel, were killed in the fire, and then have been falling in ever since. And so we think that from 23 to 2024, the density of large wood was enough that pools were starting to form and that sediment was starting to accumulate. However, again, if you combine all of these data, the median V-star at the burned unrestored meadows is still less than at the across the restored meadows. Okay, so to measure sediment grain size, we walked from the bottom of the channel to the top of the meadow channel, visually delineating areas of similar grain size, which we then mapped onto a tablet. At the end of the survey, we then added up the total area of each of these grain sizes and divided that by the total channel area to find a percent area of each of the different grain sizes. So this shows with those data set to create cumulative size curves. So I'll use before showing the rest of the data. Looking at the x-axes, these are grain sizes in millimeters. Basically, all you need to know is that the grains go from left to right. They're going from finer to coarser. When looking at the y-axis, this is the percent area grain size finer. So for example, when the y-axis equals 50%, that means that in the channel, 50% of the area, 50% of the grain size area was finer than the corresponding x-axis, which is 32 millimeters in this case. And so kind of the takeaway from this is that if the curves are shifted to the left, it means that the overall composition of the channel is finer. If the curves are shifted to the right, the overall composition coarser, and curves are solid. The solid lines are surveys that were done after restoration, and curves that have dashed lines were surveys done before restoration. Okay, so looking at the burned, unrestored meadows, Fall River had a median grain size of coarse gravel. This is the coarsest grain size that we measured across the different meadows. McCreary Meadow had a median grain size of fine gravel, and sorry, I'll just back up and say where the y-axis equals 50% is the median grain size. So when looking at McCreary Meadow, the median grain size was fine gravel, which didn't change throughout the years. It's an unrestored meadow. Again, the solid lines are after restoration, dashed lines are before restoration. And so at both middle and lower grouse meadows after restoration, from 23 to 24, we saw a fining of the grain sizes after restoration took place. And then at the unburned restored meadows, McCreary Meadow had a median grain size of fine gravel. It became fine after restoration. And Ahart Meadow had a median grain size of fine same, which was the finest that we measured across all of the different meadows. Okay, so one thing that we had about this is why our burned restored was way finer. Like the entire channel was not filled with silt. It was not filled with extremely fine post-fire sediment. One of the possible explanations, there are a few, but one of them that we'll talk about today is that these restoration structures were really good at pushing high flows across the floodplain. And so we did see large deposits of fine sediment across the floodplain, which we didn't include in our grain size surveys. So if we were to redo this study, perhaps we would include what was being deposited across the floodplain, because that turns out to be pretty important. But overall, we saw that grain size decreases after restoration. The recruit was also not as a fat capturing sediment as the restoration structures. Remember back to this plot looking at McCreary, we saw an increase in the amount of sediment captured, even though no restoration took place, but we didn't see a concurrent decrease in grain size. We didn't see a concurrent decrease in grain size at McCreary Meadow. So the takeaway is that if you want to keep as much fine sediment in these headwater meadows as possible, the restoration structures really do a great job of that, more so than the large wood at our sites. So to overlay our results on top of our hypotheses, at the burned unrestored meadows, we did see the smallest amount of sediment captured across the different meadows. We saw the most amount of sediment captured at the burned restored meadows, and then at the unburned restored meadows, we did see the amount of sediment captured fall in between the other two treatments, like we expected. Again, grain size at the burned unrestored meadows, grain size was relatively coarse. At the burned restored meadows, grain size was a little bit coarser than we expected. And then at the unburned restored meadows, grain size was a little bit finer than we expected because of Ahart Meadow having such a fine grain size after restoration. So takeaway is that structures do capture sediment across burned and unburned landscapes. Thank you very much.
Next up, we have Dr. Gray Hayes, who is a restoration ecologist with extensive experience in collaborative natural resource management and the science of disturbance ecology. Yes. He is currently serving as manager of the Occidental Arts and Ecology Center, Water Institute's California Beaver Coexistence Training and Support Program. Gray's work with the Beaver Coexistence Program is advancing wildlife coexistence through California by training coexistence professionals and providing landowners much needed support as we transition to a wildlife-friendly culture. Dr. Hayes' experience in leading collaborative approaches to restoration taps into the social science of exploring the radical center. He understands that the vast majority of USA citizens support wildlife restoration and that we are learning to work together to assure that future generations will enjoy a natural world that is richer in wildlife. Ray is excited to work with anyone interested in exploring that vision.
With the Ecology Center, a group is, how many of you know that organization? Oh, yes. If you don't, we have been long working at a process of social policy and violence process that is this you all understand, knowing the whole thing, minds and hearts. I am funded by the California Department of Fish and Wildlife to do this program. Thanks very much. We all know that species recovery is a process, and some of us are starting to understand our biggest partners in this process are beavers. And you know, for these processes work, we have much to overcome. And for beavers to be strong partners in this world, we've got a lot to work out with human-beaver conflict. This comes at a great time because beavers are cute. They do some of the most amazing work, and they are literally everywhere in our culture right now. Now is the time, folks, to make partners with beavers, to spread the word to your families and communities about how important they are for process-based restoration, for restoration that sustains itself in the very long term. We lost beavers across North America in the early age of colonialist expansion and abuse of landscapes and cultures, states. All sorts of things happened with beavers. Hats, pelts, castoreum, used to flavor foods. There were millions of beavers before these enterprises started, and wiped out many of those quite quickly. The Ecology Center started our beaver campaign. The first thing we had to overcome, we're still overcoming it, is to let people know that beavers are native to much of California. There was a dispute about that. There's still a dispute about that in parts of Southern California. This will keep playing out. But we all, I heard your enthusiasm too, are starting to integrate process-based restoration in your work and realizing how important beavers are. There are lots of people working on this. But as soon as we start doing that, the pendulum swinging back to anti-beaver quite quickly. Doesn't it? Have and non-lethal, and I'm going to talk about that non-lethal beaver coexistence world a lot today, with the idea that let's see, the idea that I can forward these slides. Beavers are spreading quite rapidly in California now with the changes in policies, with our attention to beavers and public support for them. There are pro-beaver people in many communities in California helping us along. They will spread. They're highly adaptable across the landscape. But what we must stand reality is they really need aquatic habitat they need deep water to escape predators. That's their number one thing, even though they can move into all sorts of aquatic habitats. And it was of common interest to us all in California. And of the problems beavers are causing and how we leading them across. So this is 1993, a ephemeral tributary to the American River. Keep your eye on this time series. 2009, as we have been seeing across the foothills of the Sierra Nevada, especially close to Sacramento, development spreading across these ephemeral drainages, and they are becoming perennial because of yard runoff. Wash your car, it goes into the stream, and now beavers are moving up into these neighborhoods. So the question is, that's a new development's retention basin. And the old development didn't have those because we didn't require them, but hey, beavers are doing that work now. So might beavers be helping to improve water quality and stormwater retention? Probably. And so they're also the process of fuels, which is a noun, to flows, which is a verb, is what I'm talking about here. We're trying to move away from the idea that we're just addressing fuels without addressing the flows. It's the water in the landscape, folks, that's the answer to our wildfire problems. And beavers are process-wise wetting the landscape and reducing the fuels in a way. And so I think in those neighborhoods, they should be interested in a moister landscape, right? And while they're building these dams, they're supporting a wide variety of species. We're trying to separately restore a lot of listed species behind those beaver dams and those beaver dam wetland complexes. So I'm going to show you a few of the situations that we can solve for, because many of you are going to run into beaver conflicts, and I want you to understand where beaver conflicts can be addressed by coexistence, and we can keep these beavers on the landscape quietly. Okay, so here's what they do, right? They build little dams in front of culverts. And here's a solution that's been time tested for 30 years on the East Coast, and we're new to it here in California. There are simple fence devices that will move beavers further away from the noise that triggers them to build dams and continue the flows through these culverts. And here, if you're familiar with the Central Valley, is a water control structure. Rise and fall of flooded wetlands, managed wetlands. And here is what happens to them when beavers are present. They don't work. And here is the beaver back saver that solves that issue. A big old snorkel way out in the water. Keeps the water flowing. And still, behind that thing, you can still operate boards and raise and lower water in that two-track weir. And here is the flooding of a neighborhood from a beaver dam complex. And here is what you do about that. It's a pond leveler device. They have been working for decades elsewhere, and we're just installing the first ones in California now. So the idea is that you sink this pipe in the water, you snake it up and over the dam, you lower the pipe into the dam, and lower the water level to a designed height. And that's beaver proof. In this case, we're trying to protect a manhole cover. So we set the water to do that. And it's been working even through flashy high flows. So cut down trees, and you can fence or paint the trees to keep beavers from chopping down our precious trees. And so we have trained 30 people to be beaver coexistence professionals. They're working throughout the state. There are people in your neighborhood that are willing to help with these situations, and we will provide a free site assessment with the funding we've got right now. So free and confidential. If anyone you're working with is interested in seeing if there's a non-lethal beaver coexistence solution to maintain hydrological processes. Ask these people. And so here's the website we're sending people to. I'll give you some QR codes in a second, but this is the California Beaver Help Desk that we've established, the bat phone for beavers. So we're working with all of these great people, duck clubs, parks, etc., wetlands managers, yes, homeowners associations even. You all know, don't you? Farmers, all sorts of great people. Ranchers are especially interested because they're creating irrigated pasture. Here are the QR codes that I want to share with you. We're going to be working together, aren't we, for process-based restoration that sustains itself with our largest rodent in action. A great partner for this stuff. Keep the QR codes up here for a second. There's a lot of literature up here at the front. If you're interested in the Beaver Help Desk, we've got these too. Lots of links for you. Raise your hand if you'll help spread the word about non-lethal coexistence with beavers, please. Please, really, our grant only runs a certain period of time. Now is the time to spend $800,000 across California putting in these things, like immediately. And time is of the essence. If you don't have great projects in every community, this work may not go on as fast as it can without your help. Thanks very much.
Really?
They have beaver stickers and
Yeah.
don't rush the sticker.
Dolman, who's a biologist. Sometimes a beaver person and renowned innovator in watershed management and permaculture design. In 1994, Rock co-founded the Sewing Circle LLC, Intentional Community, and the Occidental Arts and Ecology Center, known affectionately as OAEC, where he continues to act as co-director of OAEC's Permaculture Resilient Community Design Department, Wildlands Program, and the Water Institute. He has taught permaculture courses and consulted on regenerative project design and implementation in 20 countries and widely in the U.S. He began promoting the idea of bringing back beaver in California since the late 1990s, which led him to be given the Salmonid Restoration Federation's Golden Pipe Award in 2012. His latest effort, based on over 35 years of direct experience, is OAEC's Fuels to Flows campaign. Rock graduated in 1992 with honors from UC Santa Cruz in agroecology and conservation biology.
Perfect setup. We're kind of moving mountain meadows, we're moving beaver scapes, and now we're heading up into these uplands and kind of focusing on the forest zone. So I want to talk about our program called Fuels to Flows and how we're working on bringing these low-tech PBR nature-based solutions to these headwater systems. I did want to note for Sir Cal, if you guys have copies of your newsletter there, that back in 2022, there was a PBR focused newsletter, and we did have an article there about the beaver work. And so FYI to go dig out. We've been working at OAC on thinking like a watershed, what we call our Basins of Relations program, working on the salmon, the beavers. We got all kind of booklets on that and meadow restoration work. And I think increasingly also really acknowledging the process-based restoration framework. And I'll call out Dr. Karen Poe back there because she also sits on the steering committee of the Cal PBR Network, which is our new statewide entity that's been around for 5 or 6 years. Any other members of Cal PBR Network in the room who want to raise it up? Check us out. We're another wonderful network having fun. And then also, then ultimately, I think the advent of fire is what's been really interesting. Like fire's time immemorial, it's been in the landscape a long time, but I think many of us recognize, certainly in the last decades plus, the intensity of these catastrophic fires that we've been witnessing. And thankfully, the society at large and the state has really been stepping up and recognizing, we need to deal here, and fire is really important. And yet the proposal to say, manage fuel loads and vegetation on 33 million acres of land on behalf of fire resiliency is a lot of land. And that's really important. And to the degree that the primary tool says there's mostly through beneficial fire. And I think I'll show you in a second, we're all in on fire and totally on with fire, but the nexus between how we understand that the organic matter that is being removed on behalf of fire resiliency, that is not a waste product. Right? That's a beneficial biomass. And so what's our plan to deal with that organic matter, to really honor that organic resource as an on-site restoration resource? I think in the mountain meadows, we've been seeing a lot of that in the PBR work, the BDAs, the limbing and thinning, the forest fuel load, the conifer encroachment. Integrating that material to sort all that sediment out in the water is key. The beavers obviously are doing it with the cutting the green tape work. And I know there's a session at CDFW we'll be talking about cutting the green tape, but we're all into cutting rainbow tape here, right? And so there's fire tape to be cut, water tape to be cut, earth tape to be cut, biodiversity tape to be cut, and we got to cut it all together into one big rainbow. And so we really think about this organic matter as the slash, it ain't trash, it's a beneficial biomass. And how do we then reutilize and honor that resource in a holistic, integrated manner? And so our portfolio approach is really saying, as restorationists, when we're looking at a site and we're evaluating it and we're proposing to do vegetation management for fuel load mitigation, modifying fuel loads, where are those opportunities to optimize the reutilization of that resource? And maybe burn piles is all you got. Maybe biochar is what you're rolling with. Maybe chipping it on site. We heard earlier about the chipping it and laying it down into the forest and how that. But there's also opportunities to have a nexus with our waterways. And so at OEC for the last 32 years, we've been doing that on an 80-acre property with 50 acres of forest, completely overstocked, clear cut 3 times over since the 1860s. Fire suppressed for the entire time. It's a dog hair thicket, and we might have had 500 trees per acre when it was old growth, and we were sitting at 1,500 per acre. Many are dead and dying. And so, while simultaneously all that cutting and plowing and limbing and road building has increased the runoff coefficient, the water runs off faster, the velocity and volume is more intense, the erosion, the incision, the down cutting, the dewatering, and the dumping of dirt down below is also happening simultaneously. How do we pair those up and really acknowledge that, again, that slashing trash is beneficial biomass? And so, again, we're pro-fire. I'm a little pyro and we've been loving doing that work. We started burning in the 90s at OAC. We burned over those years. A couple of years ago, we worked with All Hands Ecology. I don't know if any of those folks are in the house doing prescribed burning. But our move is limit, thin it, stuff it, burn it, and then the carbon capture is in place to grab up all that fine sediment. So beneficial biomass for beneficial fire is really what we think is the opportunity nexus, because it's also related to the fact that there's this thing called the Clean Water Act, and water bodies are listed under the Clean Water Act and have 303D lists. And if you look at all those purple lines in the North Coast, those are all the listed water bodies in the North Coast that are primarily the pollutant is sediment and temperature. So things in the water world are not well either, just like they aren't in the fire world. And to not connect the dots between fire water is we will bemoan that if we don't get this once in a generation opportunity right. So what is that nexus between beneficial biomass and beneficial uses? And then also for those of us who've been working really hard on salmon recovery in the Russian River in 2000, we were down to 10 coho salmon in the entire 1,500 mile basin. We had 50,000 in the 50s. And so we've also been working on the fish game. And when we recognize that you can do all the in-stream work you want down there in the main stem of that blue line stream, but 90% of the surface area is uplands. And if you don't treat the uplands, you'll never recover the prey. Just full stop. So how do we bridge those together with beneficial biomass, beneficial fishes, and then honor the connectivity of the traditional indigenous wisdom and indigenous science and land management? And if people don't know the work of North Fork Mono Chairman Ron Good, who's an amazing fire practitioner, indigenous man out of the western slope of the Sierra Nevada there in the mid area. But I love this quote of his from a couple of years ago, and I asked both of these folks, they would give me permission to share the slide, and they did. This idea that in Ron's world, as a cultural burner, as a cultural practitioner, the relationship of cultural fire and cultural water since time immemorial is really that, fire is about water. And he was saying, everybody thinks you guys are the fire guys, but no, we're the water guys. We bring the water back. When you refresh the resources, they're going to hold more water. And that's the whole point in restoration. And Jeanette Acosta summarized it really beautifully. It's like, water's life, and fire follows water. And then beauty also follows fire and water. And so really thinking about what's the ends and what's the means of what we're doing here. And so a lot of this work we've been pushing is forest health, meadow health, ecosystem health, limbing and thinning for vegetation management, honoring that resource, integrating it into the carbon, water, fire, life cycles holistically. And these fuels as fluvial forest food flows. As we then go in and limb and thin and do all of this work in the forest, the saying goes that there are limits to growth, but you can also limit for growth, right? Fewer trees and more forest is actually workable. You got to get some permits for this thing, and I'm not going to labor this, but all of these upland waterways, what might be called a seasonal waterway or an ephemeral, intermittent, different times, but they're not perennial, they're not fish bearing, so we're way up in the headwaters. The first order streams, class 3 streams, are waters of the state. At this point, these streams, based on Sackett versus EPA in 2023, at the federal level, the Supreme Court of the U.S. on the waters of the U.S., so SCOTUS over WOTUS, and I don't know what's up with POTUS and FLOTUS, but they're not federal waters anymore relative to an Army Corps permit, a 404 permit, but they are waters of the state. So 401 fill permits with the Water Board and 1600s with CDFW are needed to place this fill in the system. So go forth and permit it appropriately. Talking about the different agencies and how city water boards. And so, I don't know how many of y'all have seen lots of projects like this, but I've got lots of photos of this where there was a really great limbing and thinning project. It's often referred to, I think, as a pilot project, as far as I can tell. Pilot up in that project. But what it took to avoid the gully there, to put the piles next to that thing, the time and energy it took to build those 4x4 piles, and then imagine the time it's going to take to bring a second crew back when it's a burn day, it's not spare the air day, to come and burn those. When in that polygon, adjacent to effectively that eroding waterway that's dumping dirt and killing coho 200 yards downstream, we could have effectively placed all of that material in there to be sequestered as carbon that's composting in situ and producing clean water and groundwater recharge, attenuating peak hydrographs while it's restoring salmon habitat in a workforce project that was socially just and ecologically restorative simultaneously, right, for less money. It's not that damn complicated, right? So, spare the air and stuff the gully for salmon and salamanders there, and let's get her done. At some point, sure, if you're too far away and don't have a gully and you're in the uplands, then we pivot to these other techniques. The in-stream upland waterway stabilization is a tactic that's appropriate to what you have as an on-site resource. It's not putting it everywhere. We're not suggesting that, but there are stuffable polygons within the landscape, and they're often associated with road drainages. We've been doing this work, like I said, for a long time. We did an intensive process where we finally got permits. Hi, my name is Rock. I'm a gully stuffing scofflaw for the last 30 years. But so we did actually get some permits after many decades of doing this legally. And so we do have a modern report over a couple of years of showing this work that you can find online, and it's sort of these pre and post photos, a lot of qualitative work on there of, again, living and thinning and prep in many cases for fire, and doing that work and mitigating head cuts, mitigating head cut migration and nick points, increasing, it's basically organic biomass aggregation that forms these beautiful compost piles. In areas where we have lower gradient and wider widths, we kind of become more like beavers, or we might fill the incised channel, and then we can get it up, we can then kick the flows out onto the terraces, turn on the switches, go to perpendicular structures, channel spanning type structures, so mix and match of parallel and perpendicular. We're always tracking of thinking about stream flow, velocity, stream power equation, and the size of the material. We lay the green gauze down, the organic matter tips up to cement the structure to the base, and then brown, green, larger limbs, strong structures with big weighty things on top. And then we pin it like a porcupine like crazy, so don't go nowhere and mobilize. So the brown, green is the compost pile, basically. That's what we're making. And then what we get in our coastal areas is it's the wettest place in the system. The water shows up and then it wets up, and that brown, green starts breaking down, and the roots grow into that thing. And redwoods and Doug fir and oaks and Madrona Bay lock it up as a root bed instantly. And it's an amazing thing. It's like a hugelkultur for the permaculture. You know that thing. There's a few heads out there. In even further dispersed sheet flow areas, we'll do these little contour carbon catchers up there in the system. And these are perpendicular plethodontid palaces, because we're working for plethodontids, which are the lungless salamanders. Because if you have the trophic web of the lungless salamanders in your leaf litter intact, you can sequester 179 pounds of more carbon, according to the study up here in Humboldt back in 2013. We ultimately stuffed just shy of 1,000 feet of channel. We measured the length, width, and depth and came up with 75 tons of organic matter that did not get burned up into the atmosphere, is composted on site, doing all of those benefits. Turns out 75 tons is equal to the amount of carbon that Jeff Bezos blew out his ass for his little 11-minute space flight. So you're welcome, Jeff. I offset your carbon footprint for your space tourism feature. So there's a whole fuels to flows workforce, and many of the folks on the fire side, the sawyers, the sorters, the swampers, and the stagers, they know that, the people building the piles. Then there's the stuffers, and the stuffers is really where you need to be a geofluvial morph understanding person, because you're building structures in the stream. And so we're really combining communities between fire communities and water communities. We've been doing this work a bunch, and there's Monona, looks right in the photo. It's regional parks. We've been working at Monte Rio. Here was a gully that got stuffed, and then the park did a burn with CAL FIRE and burned over one of our stuff projects. And notice where it didn't burn, where the stuff project brought the water up and the leaf litter didn't burn. And then it was in place when the first rains came to catch all that sediment. Building compost piles, they're not built to combust, they're built to compost. We got to stop the incisions before the ignitions. We work a lot on dealing with roads. We'd love to make fish-friendly roads and outslope everything and rolling dip everything, and that's great. But in the meantime, the shotgun culverts that are dumping, having out, there's a whole technique to deal with that. We've been working in the Navarro watershed with Trout Unlimited, Mendocino RCD, the Seas, the Ukiah Conservation Corps folks, and working in this project in Flint Creek, doing a bunch of big gully stuffing, stuffing the head cuts, going up to the switch, turning the switch on, kicking the flow into the legacy terrace, and then putting structures up in the terrace that hold the water there longer. And Dr. Mia Van Docto's unpublished work has really shown, after 5 years of data with piezometers and a control site and a treatment reach, that these structures, after 1 year of treatment, elongated so that the system leaked later longer for an extra 124 days into the stream than it would have otherwise done when it was flashy and full of dirt without the stuffing, right? So we can begin to buffer these systems. And with Monona here in Regional Parks at Sonoma RCD, we're working on a low-tech process-based restoration manual for upper watersheds. It's in tech review right now, so stay tuned when we get it published, hopefully later in the year. And there's a bunch of videos if you want to learn how to stuff gullies and get into DIY stuff, do that. So let's make haste with zero waste, because it's time to connect our fire fears and our water woes by turning the fuels into flows. People, that's what I got for you.
How does this work where areas have less precipitation? And are there any other considerations when you have much lower rain?
Yeah, that's a good question on the precip thing. So the fun part, at least the gully stuffing work, is that we're working in wherever you are with less precipitation, we're working in the wettest place in that system, because we're working where there is runoff and flow. So creating these densely compacted structures and placing them and weighting them in there and putting the heavier logs on top with the higher fuel hours, so not leaving the flashy things there and letting them get water or snow melt. on the eastern side of the Sierra above these PBR structures in some of these systems. You know, they're holding more water and dirt in there. And I think the question is how else are they not, what else are you doing with the organic matter? Because what we've seen a lot is if you want to chip it and lay it in a big map, fire folks are not happy with big layers of chips on the land. Putting them burn piles out there, and how many people actually forget their burn piles and then things are sitting there waiting to jackpot. So in the context of what we're doing in the fuels, the risk reward ratio for the benefit package on this thing, I think is within for those who may be risk averse, I think solution aversion is not warranted. Calling on people.
If you could speak more to where you did this work and you're pretty ripple effects of that, but
That to me for the fuels flow stuff or all of us? I'll start with Headwaters and we'll just work our into the Meadows. We at OAC have been doing this related work, fuels to flows and mountain meadow work throughout, I don't know, we're in 20 counties plus on up and down the coast and Southern Sierra and the Klamath Basin and throughout the Southern Cascades and within lots of communities, lots of tribal groups, NGOs, regional parks, RCDs, lots of folks. Yeah, we're polyamorous in that space. We work in.
Can you repeat the question one more time? Since I thought he was going to answer it an hour ago.
The locations of your work and all your partners and the full effects that the people are so the location of our work is in the Northern Sierra and Southern Sierra, which oftentimes are credited as having very different sediment regimes. So that's why we chose those two locations. Where this work is going next, and who is going with. Karen Pope has a talk tomorrow, which I would check out about, I'm assuming you're talking a little bit about lost model. And that's talking about have these meadows that we're working in right now, but what are the meadows that we've lost and where have we lost those meadows? And so she and Adam Cummings have done that kind of analysis across California. And so this type of meadow restoration is really applicable across all of the Sierra Nevada, at least. Yeah, let's take a further question.
Okay, I'll harken back to one of our keynote speakers this morning saying the work is about relationships, and those local community relationships then build to a larger and larger landscape, right? And so I mentioned with the Beaver Coexistence work, we are trying to establish these practices in each community in California. And I don't know how many people work across such a big geography, but I find you cross like international boundaries in California culturally, right, in different places. So we really need those projects. We're in 29 counties right now, establishing those projects so that you, wherever you live, will be able to point to a project. But that's why I'm also begging you all for more connections in more communities to establish those Beaver Coexistence devices, because we're way behind the curve. Massachusetts, East has been doing it for 30 years. So these are time tested elsewhere, but we need to check them here. And the word is spreading. People are building those relationships across vastly different groups of people in their own communities. So we're looking forward to doing more of that. Thanks for the question.
Question for the Beaver Coexistence program. I was wondering, have you had experience with Beaver conflicts with levees? And if so, what can be done for those?
Really want levees? Well, we have them. Yes. So some of the problems with levees are beavers are burrowing into them, right? And they're collapsing. And California's levee system was already kind of out of date and not well maintained. We did not have solutions for beaver burrowing into levees. The idea was that, well, we should just put chain link fence across the levee and in deep into the water so beavers can't burrow into the levees. And the people that are maintaining the levees with mowers and whatnot don't want that there, and sure would be expensive, right? So that's one of the, we're looking for ideas there, but we don't have one for levees per se right now. Thanks for the question.
Not to get us too far into the weeds of sadness and despair, but I would like to talk or just hear your reflection on permitting, especially where beavers and urban things come together. And if you've had experience interfacing with CDFW and your experience.
Right. So some of those structures I showed about beaver coexistence, you can see are in stream, right? And Cal Fish and Wildlife deals with the lake and stream bed alteration agreements per region. And each region is learning about these devices right now. And some regions have seen it, and those people are experienced with it and are saying, no need for permit. Others are still learning. And our program right now will pay for all permitting. We're developing good relationships with each region, as are the RCDs that are working with us. It's not insurmountable. It's not a big deal for Cal Fish and Wildlife in particular. Do not fear that permit.
And I mean, I think I spoke a bit on the permitting for the uplands of these intermittent systems, but like Ray said, in the same way with the Regional Water Board and CWW, they have their what happens in Sacramento, and then there's what happens in the regions. And region by region is a really different thing. The North Coast region, where we are now for the Water Board, the North Coast Water Board, and then Region 2 for CWW down south, we have really long-term relationships with people in those regions that we've built over years, have trust, to recognize that there's a best management practices, and we're doing training with installers and a QA/QC thing, and they get the benefit of the risk reward need right now to offset that, and are whether the green tape got cut or not, are lubricating the capacity to make these permits as, I don't like the phrase streamlining, although we are lining some streams with this organic matter. Other regions are a little bit tougher, so it's kind of a region by region game, although we are working in Sacramento to ultimately create more almost a programmatic framework for some of this upland related stuff.
I have a question for Ray.
Okay.
And my question is about scalability. I'm curious about if you were able to do these projects like mini beavers on a single stream, or if they did like one in different places. Like how do you get it? Like do one big project, or is it about many teeny projects? And how does that work with landowners and like these small parcels, things like that?
Sure. I would say all of the above. Right now, we're working in stream regions with 7 and 8 pond levelers through the thing over the course of a mile. In some cases, we're dealing with one landowner with a small parcel, and we're just doing one project until the neighbors get used to it. And so all of the above, and the scalability is this, right? Right now, as I say, we're trying to establish example projects throughout the state, show people what it takes and the costs. And I mentioned we have 30 people that are establishing businesses to do this. Our grant money won't run forever. These are not expensive projects. They're actually more affordable than the continually going out there and shooting beavers with your own time or somebody else's that you're hiring. And so we're also showing people that this beaver coexistence work will be more sustainable than shooting the next beaver comes in, more chaos over and over and over again until never. It just keeps going on. Beavers will come. So I think we're teaching people the scalability for affordability is the way to go as well right now. Thanks.
Kathy Mueller on that?
On to another talk.
All right. One of our Beaver Coex people is attending the conference. So you see someone named Kathy Mueller, chat her up. She's great.
PCI project right now, I'm trying to determine how high older beaver dams for a high flow impacts in like severely incised streams as well. So I was wondering if you built your DDA for the cold depth, or how high did you put your DDA to manage them?
The design of the structure build was done by Swiftwater Design, who the U.S. Forest Service contracted them. But the idea, though, if you remember the maps, they were basically riddled with PDAs. So the idea is the more VDAs, the better. And we also had some reaches that were incised up to a couple of meters. And definitely during the first couple of years, the VDAs did not go up to floodplain height. Like and swift waters come back year after year and are starting to build up the height of those VDAs in order to slowly reach the floodplain. So it is really iterative. It's not like a one-time deal. But I do think that, especially if you're about VDAs getting blown out, definitely a lot of VDAs upstream to kind of slow the flows as it's coming down, push it across the floodplain so that you can maintain your VDAs.
And while Kevin Swift is over in France and England right now talking about this work, I can say, and just shout out Garrett right here with Symbiotic Restoration, who is another contractor, process-based restoration contractor from this part of the world, who does work all over the state. So shout out Garrett for that work. Or if I don't know if anybody here is from Anna Branch, Anna Branch in the house. So there's a series of other contracting firms in addition to water design and others. So go find those people because it's an it depends answer.
I've got two questions for Greg on your presentation. Great job. With you're showing that graph there about how beavers are decimated and such. My first question is, how is it looking with historic population compared to present population for beavers statewide? How close are we getting back to historic situations with population distribution? And number two, with how you brought all those new things that beavers being portrayed in the media, whether it's books, films, what's the likelihood of that media helping to shape a more positive public perception of beavers?
Okay, yeah, I'll take the second question first. How is this the large media outreach doing for building support for beavers? Is that right? And how many of you have heard from people in your families and networks about beavers from people that don't know anything about biology? Anybody? Yeah, a few, right? 20%, something like that. And that, 20% of, our populations, it's really going wild. And at the same time, in our culture that is like, oh, are you pro beaver? Are you anti beaver? Those conversations are going on, right? And so, like so many things, if you don't talk beavers with your family at Thanksgiving, right? Not yet. Although cute animals, like the majority of the U.S. citizens, support healthy wildlife across all sorts of political spheres. So it should be safe to bring this stuff up with your relatives and just talk about the beauty of beavers and how cool they are and see how it goes. Populations of beavers now as opposed to historically, and how is that trajectory working? I don't know if Brock can weigh in on that as well.
A good question on that one. North America, at time of contact, the estimate was 60 to 400 million beaver. Estimate in the continent right now is say 10 million beaver in California. There isn't a solid number for the actual number of beavers we have right now. In 1911, the estimate was we were down to 1,000 beavers. And so the legislature kicked in and there was a beaver protection thing in 1911. It's one of the earliest wildlife conservation legislative things in the nation at that time. And then there's been a lot of back and forth. The state actually relocated 1,200 beavers from 1930 to 1950, ending with parachuting them in off of Highway 50 in El Dorado after Idaho did that in 48. If you haven't seen that YouTube video, go to Idaho Parachute Beavers. I would say that the California Department of Fish and Wildlife, now that they have a actual beaver restoration program with permanent staff, we passed a beaver bill, so they're permanently funded. They are working on that attempt at trying to figure out where the beavers are and roughly how many beavers there are and what's going on with that population and are we coexisting with them. Now that we have a depredation policy that reduces the lethal relationship to more of a coexistence relationship, those numbers are coming up from We used to kill thousands of beavers a year in California, and that's going down. So it's a really interesting moving target, and no one's got a solid answer. And if you're looking for a master's thesis, there's opportunity to be had there. But the department is working on it right now towards developing a beaver management plan, which hopefully should come out in the next couple of years.
And I'll add to that, please. There's an app for your phone called Beaver. Seriously. And those citizen science data are crucial to getting your question. We need iBeaver data. iNaturalist helps, but it doesn't get to beaver specific things like how recent is the dam building and all that. That's in iBeaver. We've got scientists standing by to do the analysis. We need to populate iNaturalist and iBeaver with more beaver information because the state's not collecting it. It's up to us.
All right, great. Thanks, everybody. And thank you all.